Okay. All right. So we're gonna go back to the basics, reducing radicals. So what you want to do is basically break everything into squares because we know if we have a square inside it, they cancel out, right? And we're also going to use this property from back in the day. It says if you have two factors inside, then you can separate them into two separate radicals. So what you want to do is get everything that could be reduced into the front. Uh, 54 is 9 times 6, right? So I'm choosing these factors on purpose, and I'm putting the z, well, I'll move it in a second. But whenever you have a number inside the radical, you're looking for a squared factor. So like 4, 16, 9, those kinds of numbers. 9 is the best one, the biggest one. That's why it's chosen. Then once you have everything set up, oops. Once you have everything set up, just put the things that are squared numbers in front, and then anything with an even power, put that in front. Everything else will not come out. It'll stay inside. So technically, this is what actually happens. You separate the 9, you separate the z, and the rest stays right there. So square root of 9 is 3. Now, whenever you have a power on this, you need it to be even because it's going to be cut in half. So the square root cuts this in half, leaving you with the z to the fourth. And that's it. This cannot be reduced further. So the goal, if you have a number, look for a squared factor. If you have a high power, make sure it's even. If it's already even, there's nothing to do. We just cut it in half, pull it out. And the reason that happens, right? Because remember, the nth root of any number is equal to that number to the fractional power. So square root of z to the 8 means z to the 8 to the 1/2. 8 times a half is why it's cut in half. Okay? Do y'all remember the radical rules? Any questions on any of the steps, or in case you did forget? Excuse me. Yeah. Moving on then. Number 2, let's see if it's the same thing. Yeah, this is pretty much the same, although it's a cube. So let's go ahead and do it real quick. It's the same instruction as the first one. It's just that it's a cube root. And we're going to use the same properties. So you know how earlier we said I wanted an even power, right? Now we're going to want a power that's divisible by 3. We picked even earlier because it was divisible by 2, and this is a square root, or root 2. So first thing I gotta do is look at the number and figure out, okay, what factor of 40 is a cube? What cubed factor is inside 40? What do y'all think? I don't have all the cubes memorized, but it should be one of the small ones. Okay. Well, what are the cubes? The only ones I remember from memory would be 8, 27, 64. Those are the only ones I remember. After that, I got to look it up. But I know 8 goes into 40, right? So 8 is a cube. So I'm choosing to break down 40 like this. Do you see why we chose that? Looks like the V is floating. So now we want to have a V that is divisible, it has a power that is divisible by 3. So what I'm going to do is purposely break a little piece off, right? Because you agree that V to the ninth times V to the first is the same as V to the 10th. But remember, V squared times V cubed means 2 plus 3, right? So, and we know that V5 means just 5 V's. So I can just break one off and write it this way. Do you all agree? Anytime I want. See what I mean? Just in case you forget the rules of exponents. So what I did is, well, I got 10 V's, so I'm going to write it as 9V and then, or V to the 9 and another V. So once you have it set up, prepare the ones you want to break off on purpose in front, so no extra step. And these are going to stay inside because they're not cubes. Only the cubes are going to come out. Okay. So V cubed of the 8, or sorry, cube root of 8, cube root of the V, and then the rest just going to stay in there. So cube root of 8 is a 2. V9 cube rooted is going to be 9 divided by 3. So what you get is V3. And then that's it. So when it's a higher power, it's a little weird, but the rule is try to match, right, the powers and find the factor that makes sense. Do you all see why I chose 8? Do you see why I changed it to V to the ninth? Okay, so no questions on number 2. All right, let's move on then. Just don't be afraid to ask because this is the time to ask review questions. Let's look at number 3. So it looks like the first few questions so far is all rules of exponents. And I'll send you all these notes when we're done. Thanks, Amanda. Appreciate it. I want to put simplify, but basically they want you to deal with this negative exponent. So real quick, let me put the rule that you're going to need. So x to the negative n is the same as 1 over x to that same power. So basically, it does the power changes to a positive. The way I think about it is you bring this to the bottom, and it just as soon as you cross the line, you change the sign. Because if it's on the bottom and it's negative, you can bring it up and it becomes positive. Now, also, the following is true. If you have x to the n and it's a negative, it's really the same rule. It means take the reciprocal. So these four here are this first one and the third one are really the same thing, just represented differently. So basically, let me see, we'll number these. So that means that if you have a fraction, let's say x over y to the negative n power, that means just flip it over. And I think I sent you all the rules of exponents, right? If not, I will soon. So using number 5, this flips over. That's it. And then square it. Square the top, square the bottom. No big deal, right? Any questions on number 3? Okay. They're not too bad so far. That's good. So write the following as a radical expression. Yeah, you can put you keep any sheets that I sent you. And if you need or if you want to summarize your own formula sheet on a blank piece of paper, that's fine. Just no examples, just formulas. Okay, what was I? Cool. Okay. So remember, when you have a fractional power like this, let's say m to the n, this is the same as uh, oh, you mean the squares and all that stuff? Yeah, that's totally fine. I don't expect you to memorize that stuff. As far as calculator, you can use them, but you have to show your work like we did here, just some simple stuff. Gotta show steps. The right answer doesn't matter. No, the work does. All right, so you see the root here, the n, that's the index here, and the power m is the power on the a. So that's the same as saying this. So notice the index n is 7. So what is my root going to become? Yeah, it's going to be the seventh root of a, and then the 4 can be inside or it can be outside. Let's see what the Homer, the Alex preferred the top one, but they're both fine. So just use this and that's it. Yeah, there's not much to do. Is use the definition and the formula. Are there any questions about that? All right. Let me know anytime if something doesn't make sense. They're going to move on to something else. So expect the first few questions to be about the basics, rules of exponents, radicals, that kind of stuff. Then the next few questions will be quadratic stuff. So this is the type that we're solving. Okay. So how would y'all solve this? How would you start it? Mm-hmm. Yeah, whenever doing quadratic, almost every single time, you should set it to 0. So I'm going to add over that 24W to the right-hand side. Now you're right, Amanda. So we're moving everything over here, right? Now in this form, is it more obvious how we should solve it? Mm-hmm. Yeah, factor, right? GCF. What do they have in common? These two terms.
They can be divided by 6, no?
Yeah, they're both divisible by 6 for sure. Oops, 1 second. There it goes. And what else do they have in common? 6 and something else, right? Yeah, both have W. I just saw your message there. So factor 6W out of there. And we're going to get W plus, what is that? 4? So what do we do at this point? Yeah, so we have the zero factor property that says we can do this. Which is the goal, right? But this is the only reason we care about factoring so much is to do this, then solve. So W is 0, W is -4. Let's skip some minor algebra here and there, but do you have any questions on the algebra? Is this okay?
Wait, I'm confused on why there was a -4.
Oh, yeah, sure. So if I have to solve for W, what would you do right here?
Subtract the 4.
Subtract.
Yeah, you have to, right? So then it becomes negative that way.
Got it. Thank you.
Yeah, no worries. Thanks for asking. Any other questions on 5? Because that's all they want. So the first strategy for solving quadratic is check if there's a GCF. Usually when you see just two terms like this, GCF is the way to go. There's no need to be doing quadratic formula or something crazy like that. You know, AC method or quadratic or the trial and error and all that stuff. It's unnecessary. This is much simpler. Let me see what the next one is. No, here it is. All right, so what's the first thing you should always do? Yeah, you know, set it to 0. Now, you can move this entire thing over if you wanted to, or we can score it first and then move all the terms over. It doesn't matter. I feel like this would be easier to score it first, but again, it doesn't matter. Square this stuff, you're going to get b squared minus 14b plus 49. You're going to multiply this out, right? Gets you 3 terms. You could try and see if they factor, but if they end up being different, it wouldn't be helpful. So I'm gonna move everything over now, right? I'm gonna get the v's together. So subtract this. Well, let me write it down so you don't forget. So minus v squared minus v squared plus 14v plus 14v minus 49 minus 49. Now you could just go ahead and add it here. But what I'm going to do is show you, I'm going to pair them together and then do it in the next step. So I'm subtracting the two squares. I'm combining the v. Oops, I wrote it all tiny then. So I moved everything over. How cool with that work here, the algebra. Any issues so far? Okay. So once you get combine all your like terms, you end up with this. It looks like we can factor with trial and error. Do y'all see how to factor this?
Yes, I think it should be um, v plus 1 and v minus 5.
Close. But they have to add up to positive 4, so switch the signs, right?
Yes, sir.
Yeah, I'm not always gotta be careful. I sometimes mess that up too. I'm like, if I add these up, do I get the middle term? No, we're good. So final step, we get our views, and that's it. Oops, let me move this up. Set each factor to 0. That's the whole point of factoring. Subtract 5 on both sides gets me here. Add the 1 on both sides gets me there. Any questions on the algebra? You guys cool on 6? All right, number 7 then. Here it tells us which technique to use. Let's solve with square root property, which means we square root both sides, right? That's what it wants us to do. So if I want to square root both sides, what do I have to do first? So how does it need to be set up? Yeah. Whenever you use square root property, you need to have them. We need to have one term on both sides. This is a single term. So add the 40 over. Let's square root both sides. Yeah, there we go. And this is when we need to reduce that square root, right? Although when we do that, we have to add the plus or minus. But don't forget. So w plus 10 is equal to plus or minus root 40. So this is a square root. So what is a squared factor inside 40? That's a good one. A would be a cube. So like what times what is 40, but is also squared? Yeah, I think 4 and 10 might be the only option. I was thinking 8 for a second too. I was like, well, so remember we said, oh, you separate these, right? Square root the 4 gets us to here. Subtract the 10 over gets us to here. So these are our two answers. It's not very pretty. That's how it goes. Two solutions. So you would type these two, maybe with a comma, or maybe it has two boxes on it. Any questions on 7? Is that okay? So the two things to remember, if it says use square root property, or if you think it's a good idea, make sure you only have one term on each side, or set it up so you can do it. Once you do it, don't forget the plus or minus. If you got that down, then the rest is just simplifying and moving the 10 over or whatever. Following for W. Number 8. Solve by completing the square. So remember we said to complete the square, we got to find that special number and add it to both sides. So this 1 isn't going to help us at all. So I'm going to go ahead and move it over just to make it more obvious what we're going to do. I'm going to leave a special blank here, which is what I'm going to add the 1 over. So the special number to complete the square is half the b term, right? Remember, when I say b term, I'm talking about the general quadratic. B is equal to -2. Half of that is -1. Square that, and that's a positive 1, right? So that's the magical number I'm going to add to both sides. To add 1, add 1. So now that this is completed, the square is complete. It will factor pretty. It will factor like a perfect square. So it's going to be factors of 1 that add up to -2. So -1, -1. Now it's squared. Do y'all remember this? Any questions on completing the square? Is this part okay? You mean like which term? Talking about this one or coefficient of x word?
The x square. Like if it wasn't 1, it goes like a
Yeah,
5 or something.
if it's not 1, you'd have to factor it out of these first two terms. So you would move over the 1 like we did here, then you'd factor it. We'll see if there's one like that. Let me see. No, I guess not. Well, there's time after we could try one from the homework. Okay. So now we complete the square, and do you see why we did it, right? We can use the square root property. So square root both sides. And then add your plus or minus. This gets me x minus 1. This gets me, add the 1 over, and that gets me to here. Yeah, so the 2 happened because, so let's go from the start, right? First step, I said, let's move the 1 over by adding 1 to both sides. Then once I did that, I said we need to complete the square. So I said, well, these are the 2 blank spots. So I got to do it to both sides. So what is the special number that completes it? That special number is found with this process here. You take the b term, which is -2, divide it in half, square it, giving you this. Add it to both sides, which will then give me this 2, 1 plus 1 here. And then that's completing the square. So this factors as a perfect square. And this is what we mean by perfect square. X minus 1 squared. Once it's ready, we square root both sides and we end up here. Are there any questions on number 8? The previous problem, we did not complete the square. That was, the previous problem just said square root both sides, I think, right? Let me see. Yeah, so on 7, it said just use the square root property. It's a different technique, although we ended up using the square root property. This one just straight up starts here, right? Or here. So on this one, we completed the square because that was the instructions. And once we complete it, we end up with an opportunity to use the square root property, which then gets us the answer. But originally we couldn't do it. So whenever you complete the square, you're going to end up wanting to, most of the time, square root both sides. Okay. Yeah, so to complete the square, you will always add b over 2 squared to both sides if you have an equation. If you don't have an equation, then you'd have to add it to that single side and then subtract it, which we did an example in the notes. We did a couple, I think. Does that make sense? Or whenever you complete the square. So, okay. In order to complete the square, we have to find the b over 2 term, square it, and add it to both sides, which we did here. Once that's done, the square is complete, which factored into a square. That was the goal. But once we got there, we're like, hey, you know what? We can still square root both sides to solve for x. If we were just completing the square root just for fun and not solving anything, it would be a little bit different, which we did on the notes. Remember, we had a bunch of examples where we just completed the square just to learn how to do it, and then we applied it to something like this to solve something. If the b is missing, then the question might be easier. It will turn into number 7, right? Check it out. Or, yeah, it would basically be x squared equals a number, which would allow you to go straight to the square root property. So when a term is missing, it usually becomes easier. Usually. Okay. Number 9, we basically have to do quadratic formula, but in this example, we're going to end up with complex solutions. Let me find a problem. Okay. So remember, x equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Our a is 1, our b is negative 3, and our c is 4. To plug it all in, negative 3. Negative 3 squared minus 4 times 1 times c. There we go. That becomes positive 3 plus or minus square root of 9 minus 16. 9 minus 16 is what? Negative? All
7.
right. Thanks. So this is when the complex part shows up. So the solution will be 3. I think they can write it this way. It's the same as 3 plus square root 7i over 2 and 3 minus square root 7i over 2. They could also write it this way, 3 halves plus root 7i over 2, 3 minus root 7i, both over 2. There. Yeah, it should have an I, the complex. Yeah, the root negative 7 makes the I come out. Once that's done, you just do your solutions. Anyway, any questions on using the formula? Y'all see what happened or not? All right. Go to the next one. That was number 9, I guess. No, actually, we just did 10. On this one, I'm going to skip because it's still the same. It's basically another. Let me show you the solution. Can y'all see question 11? So they have this equation that models the ball being thrown into the air. Let's see. Find all values of t for which the ball height is 12 meters. So they want to know when, at what time, h is equal to 12. So how would y'all start this? I think the starting
Oh.
is the hardest part.
Substitute the h for the 12.
Yeah, that's it. So once we do that, you would set it to 0 and use quadratic formula, and you're done. So it turns into the same question as before. So check it out. Set the height equal to 12. So there it is. Subtract it over, and which gives you this. And then use your quadratic formula. So ABC is right there. Plug in your numbers, and you're going to get 2 times. Which makes sense because if you throw it upward, it hits 12, and then it comes back down and hits 12 again. So there should be 2 times when this happens. So on the way up and on the way down. So you would give two answers. But I think the only new thing is set it equal to 12 and then solve for time. Does that make sense? Okay, let's move on to something else. Excuse me. That question. 12 is something we did before, so let's go and do it anyway. The length of a rectangle is 3 yards more than twice the width. Which they call x. The area is 230 yards squared. Okay, so we got to make an equation for the part A says represents the relationship, and then we solve for the dimensions. All right, so remember, area is equal to length times width. They said that, I feel like there should be a comma there. Width is x, and length is 3 more than twice the width. So 3 more than twice the width, which is the same as this, right? They told us that the area is 230. So plug everything in and we'll have the relationship they want. This will be 230 equal to 3 or 2x plus 3 times x, which gives us 2x squared plus 3x. And if we solve for that, set it to 0, we end up here. Right? So this is part A, basically. Give them the equation. I think the first one or the second one is fine, like these two. But is there any questions on the setup and how we got this formula? Anyway, so now we just solve for x, right? I'm pretty sure it's going to be quadratic formula. Let me see. No, actually, you can factor it. But, But these numbers are ugly, so trial and error and AC method would be annoying. So no matter what technique you use, it's going to be annoying. So I'm just going to go ahead and do quadratic. Alex does trial and error straight up, which I think is kind of silly. Like, unless you're really good at factoring, I wouldn't do that. So I'm going to use quadratic formula and say that this is negative b plus or minus the square root of b squared plus or minus 4 times a times c. That becomes negative 3 plus or minus 9 plus, actually, there's no plus or minus in here. That's weird. So negative 8 times negative 230. I don't know what that is. Let's get the calculator out. Going to be positive 1840 over 4. Negative 3 plus or minus the square root of 1849 over 4, which I think is a square now. Yeah. 43 squared is, oops, 1849. See if this simplifies. I think it does a little bit. Negative 3. Let me do it over here. Negative 3 plus 43 over 4 is, and then we have negative 3 minus 43 over 4. That becomes 40 over 4. This becomes negative 46 over 4. So this is 10. And what is that? 23 halves, I guess. Anyway, I feel like we got lots of weeds there. What is x again? What are we doing?
It was the rectangle, no?
We're looking for the dimensions, right? So this is, of course, not x is the width. So does negative 23 over 2 make sense?
No.
It does not. So width is 10. The length is equal to 2 times the width plus 3, which is 23, right? Guess I should show the work there. 2 times 10 plus 3. Any questions on finding the width and length? Or the quadratic formula step or the setup? Okay. Move on to 13. Okay. So this is an absolute value problem. Whenever you're doing these, you want to isolate the part that has the absolute values, the bars, and then remove the bars. So whenever, let me show you a little formula. If you have absolute value of x equals to some number, let's call it some constant c, removing it means you get two equations, the positive and negative version. So you solve two separate ones. So before we remove it, though, it has to be by itself. So move the 7 over by subtraction. So you get this guy by itself. 31 minus 7. 24, right? Is that right? Yeah. So now remove the bars. If I remove them, solve these two separately, and that's it. Add the 4. That gets me to here. Divide by 4. That gets me to here. Okay, now add the 4 over here to the other one. That gets me to negative 20. Divide by 4. Gets me there. Any questions on 13? Okay. Let me look at 14. Yeah, 14 is not that interesting. But we'll go over it real quick. We won't work this one out, but I want you to see the answer or how they do it. So it's very similar to the square root, right? We said if you want to get rid of the square root, then in this case it's a cube. You first get this part by itself, right? And so they move the 24 over right here to plus 24. Then they cube root both sides, which is where this came from. They skipped a little minor step where the cube root and this cancel, but that's okay. But notice that because it's an odd root, you don't have to do the plus or minus. You just leave it as is. Then you add the 9 over, check if you can simplify the inside, which you can. There's an 8 inside 24. 8 is 2 cubed. These cancel, leaving you with a 2. 3 stays in there. That 9 was from the other side. But you see that the idea is the same as the square root. You just have to follow the cube root properties. Okay. So we're moving on to something else. Let me see what the next one is. 15. Get it here. Yeah, 15 is a hard one. Let's go ahead and do that. This is called a rational equation. So write the note there in case you want to look at more examples somewhere. Okay. So whenever you do rational expressions, which is basically an equation with a, or rational equations, is basically an equation that has fraction type fractions with variables in them. That's all. It doesn't matter if they're variables or numbers. The technique will be the same. You want to cancel fractions because they're in the way. So whenever you have an equation, you can do that. So cancel all fractions before you start solving by multiplying both sides by the LCD of all your terms. So the easiest way to see what the LCD is going to be is factor everything first. Now you can see, right, LCD. So this fraction has W minus 5. This has W minus 5 and 2. So your LCD will be this guy. So multiply this on every single term, and all your fractions will cancel. So you can see these will cancel. All of this will cancel. And now we have 3 times 2 equal to 7 minus 2 times w minus 5. No more fractions. Is there any questions about what happened there? Okay. So once the fractions are gone, this is just a basic solve for x kind of question, right? Just solve for w. So this becomes 6. Do your PEMDAS, right? Parentheses first. So negative 2 times w, negative 2 times negative 5, the positive. Combine like terms. 7 plus 10 is right here. Now we have to solve for w, so we got to get all the numbers on the other side. So subtract the 17 over here. So 6 minus 17 is what? Negative, right? Is that okay so far? Yeah, that's it. Now, yeah, it'll be fine. Let me show you what they did. Just we have two frame of references. Oh, what, 17? Oh, 7 plus 10. This, I just combined the terms. I left the negative 2w right there. Once that happened, I moved it over and solved for the w. Okay. So I think that they did the same thing we did. Find the LCD, which is this. Multiply every term by that LCD. So this times the first term, this times the other two terms, right? They cancel, leaving me with the 6. These cancel, leaving me with the 7, right? The 7. 2 times 3 is the 6. And then they just have this left over. Just multiply your negative 2, gets us to here, and then solve for w gets us to there. And they added an extra note. They said w cannot be 5 because it would make it would cause division by 0. So as long as your answer is not that, you'll be good. Right? Always check like what are the values that are not allowed? What would cause division by 0? Because if those pop out as solutions, then that's a problem. Anyway, you guys cool on 15? '16 is similar. Move to 18. All right, so this is the radical equation types. So solve for x. Alrighty. So if you want to solve for x, you're gonna have to get that radical out of the way because the x is trapped inside. So this is when you gotta square both sides in order to get rid of your radical. Well, raise it to the power of whatever your root is. So if this was cube root, you would raise both sides to the cube power of 3. But I don't think that'll come up. But anyway, square both sides in order to cancel your radical. So that gets us to here. Square both sides. So whenever you square both sides, there's a possibility that you introduced erroneous solutions, is what they call them. So you might get some answers that are not real. That don't. In other words, well, I shouldn't say that. But we get solutions that just aren't going to work. Okay, you get like extra solutions because we squared. So set it to 0. Let's move everything over. There we go. Factor this guy, that'll be -7 minus 3. So x equals 7. Oops, sorry, shouldn't skip steps. X minus 7 equals 0. X minus 3 equals 0. So add the 7 over, add the 3 over. Now, we got to test them. So test x equals 7. So plug it into the original. 6 times 7 minus 17. 7 minus 2. 6 times 7, what is that? 42, right? Minus 17. This is 5, 5. This is true, right? Sorry. So I plugged in 7, and I got equality. So it is a solution. Now test x equals 3. Square root of 6 times 3 minus 17. is equal to 3 minus 2. This will be 18 minus 17, square root of 1 is equal to 1. Yeah, it looks like we're good. So both solutions work, so you would type in both, but you have to test them because it's possible that they're both fake answers and neither one works. That happens. Or just one works sometimes. Any questions on 18? Not really. Sometimes, it depends, right? Like, for example, if you knew that this result is going to be negative, let's say I plug in a number and I get a negative. There's no way square root of something will equal a negative number. So that can be easily ruled out and can be justified because of it. So some simple stuff like that you could find out, but you know, some of the things maybe isn't easy when you can do in your head, but for the most part, that's the only case where it's clear. If one of the sides ends up as a negative when you plug in your test, you can stop right there. Because it shouldn't happen. It can't happen. Nineteen is kind of weird, so let's do it. X minus 6 raised to the 3/4 equal to negative 3. Where x is a real number. So I need to cancel the 3/4. So what you do is you raise both sides to the reciprocal power. Oops, I shouldn't do negative. That's an accident. Does not need to be negative. It shouldn't be. So remember, right, when you have a rules of exponent says when you have a power raised to another power, you get that same power times the other power, right? So this becomes x minus 6. Just in case you forget, I'm going to show the work here. These will cancel. Does that make sense? Why we chose the 4/3? Now, on this side, you have to remember the rules I told you earlier. The bottom is the index of the root. The top is the power. So let me see how they frame the solution. I don't think it's going to be pretty. Nah. It will not be pretty. Okay. So basically, it's going to be cube root of -3 raised to the 4th power, which is not, that's just gross, you know. Oh well. If I multiply that 4 times, I would get, well, I could do this, I guess. Again, it's gonna be ugly no matter what. So I'm gonna add the 6 over. What we could do, hmm, it shouldn't be negative anymore because it's gonna be 4 of them. I'm trying to think of an easy way to explain this. Here, we know that this is going to be 81, right? Positive. 3 times 3 is 9, times 3 is 27, times 3 is 81, correct? So 81 doesn't have a cube inside of it, but we know, we just said it, that there's a 27 in there. Yeah. So that it comes out as a 3 cube root of 3. That's the most simplified we're going to get. As you can see, it's not, it's whatever, right? But we still have to test it. That is, it has to be a calculator time. And I don't have mine. Well, let me check. Okay. What I advise you to do, I'll do it on the computer, but put all this right here in there and then do the calculator and see, is this going to be -3? It's not, but let's see. Three times, is there a cube root function? Don't think so. I'll have to use this for now. Is that in fact 3 or -3? I'm actually quite surprised at this. Well, oh, I see what's going to happen. Y'all can see the calculator, right? So replace x with this. 6 minus 6 is 0, so these will be gone. And then we have this to multiply with that power, which will undo itself, end up with a +3. But if we would have been more clever, we should have seen the answer right away. Like, check it out. Without doing any work, you could have justified and said, the fourth root is even. There's no way it'll be equal to a negative. If you would have just wrote that in English, you could have said there's no solution. But if you plug it in, you'll also see, once you do all the work, that it's not equal to, that it's not going to be equal to -3. So either you do the work and find out, or remember that an even root can never give you a negative output. It's not going to happen, right? Unless there's a negative in front of this, which would be a different problem. So does that make sense? It's like, for example, if I had square root of 2x equal to -3, and like that has no solution. It's not going to happen. I think I should have known if I saw it, even though it's written like this, it's the same thing. There's no solutions here. And then when you try to solve it, you're going to see it. And if you don't see it, you're going to see it when you plug it in, which is what just happened. Anyway, any questions on 19? All right, cool. Let me look at the other problems. Yeah, I didn't realize there was so many of them. Gee. The actual test won't be as long as a review. They just give you more so you can practice. The actual exam will be shorter and a little bit easier. Review and homework are always harder than the actual test. It's, that's how it's supposed to be anyway. Solving an equation. Yeah, there is a time limit. I'll check what that is later. I don't know off the top of my head. So there's a few questions where they don't appear to be quadratic or they look strange, and then you can use substitution to make them easier. Okay. So basically you say, you know what? Let W equal y squared. So rewrite the problem so it's a little more obvious. We know that y squared squared is the same as y to the fourth, right? Yeah, I only did that so you can see it because I'm going to substitute the y squared with the w. So this becomes w squared minus 6w. So now we have a basic quadratic. So set it to 0 by adding the 5 on both sides. Factor this new dummy variable w. And that's it. Well, almost. So we found w, but w was made up. So bring back y squared. So y squared equals 5, y squared equals 1. So right here, I'm write a note for you. Use the substitution to make this into an easier quadratic problem. Once solved, bring back the original variable. Because w was made up, so who cares about that? We were looking for y. Now, how would you solve for y here? Yeah. Yeah, it's a substitution, Ayush. Yeah, we need to square both sides, and then now we're good. So y is equal to plus or minus root 5. Y is equal to plus or minus 1. Any questions on 20? Second, let me find. So there's a couple in the review that are just use or substitution, whatever. So let's move on to something else. So I'm going to skip some of this next few questions. Let me show you why. These are the circle problems. There's quite a few, but I think the easy one is this one. So remember, if they give you the center and the radius or diameter, you pretty much have the whole thing, right? So the only thing you need for circle problems is remember this formula. And remember that radius is twice the diameter, right? Or diameter is twice the radius. So find the radius by cutting that in half. There it is. Plug it in there, right there. Remember we said that h and k will always be the opposite of the center. So if it's 4, it becomes -4. If it's -9, it becomes +9. And it's because of the built-in negatives. Okay. So that's it. You just plug in the information, and that's your answer. That is your circle. You'll see or have any issues with 20, what is this? 22. Okay. Make sure the next circle question. So this one has a center and a point. So we did a few of these. Did you want to do this one again? Okay. Let's do it on the paper. 21. No, what number is it? I don't even know. $23. And an equation of the circle that has center 5, 6, and passes through 6, -1. So just use the standard form. Yeah. We got the center x minus 5 becomes the opposite. Y minus 6. We need to find r. So plug in x equals 6, y equals -1 from the point, right? And then solve for r. So we're going to get 6 minus 5 plus -1 minus 6 equals r squared. To add all that up, we're going to get 1 squared plus, what is that? Negative 1 plus 49 to 50. R is equal to the square root of 50. Technically plus or minus, but we're talking about radius, so plug it in and we're good. Remember that r squared would be 50, correct? So plugging everything into your formula gets us to here. Any questions on 23? All right. Yes, cool on 23, right? Let's see. Let's move on to 25. So 25 is the vertical line test. Sorry, this review is super long. Sorry, guys. Do you remember how to tell if it's a function using the vertical line test? Oh, vertically. Horizontally would be one-to-one stuff. So if you draw vertical, and if you hit, yeah, you can't touch two or more. Otherwise, oops, my hand was stupid. Right. Where is that thingy? Here it is. Draw a vertical line, and it hits more than once. Point on your graph, not a function. So you would say no here. So that one's a no. So check the ones that are functions. So I'm not checking one. What do you guys think about number 2? Is it a function? Can you draw it somewhere that hits twice? So this is a function. So yes. What about this? Yeah, not a function because I hit those two points over there, right? So nope. This looks like it's a function, but when you draw it, we should always remember that circles are never functions, they're just relations. And no matter how you draw it, you're actually going to hit 2 all the time. So not a function. Nope. Looks like these, just those 2, right? That's it. Any questions about the vertical line test? Okay, this is the next one. This is, I forgot the number. 26. This is 26. So on the time of domain, right? Just see how far does it go to the right. So it goes on forever. So eventually it's going to hit all your x's on the left and all your x's on the right and left. So we'll be negative infinity to infinity because it just keeps going down, or it keeps going to left and right forever. Now, range is how high and how low did it go? So there's a high point and then there's an infinite low point. So domain will be negative infinity to infinity. For range, what's the highest point? They tell me the vertex for a reason. We're going to put bracket 3, and then it keeps going down forever. Although the smallest or most negative always goes first, so that's wrong. So negative infinity up until 3, and then it goes back down again. So you always put parentheses on infinity or negative infinity every time. You put bracket if it actually lands on it. So we're actually on 3, so we have to include it. So the bracket means I'm including that number and everything below it. If I put parentheses in, that means everything below 3 is cool, but not above. Or equal to, sorry. Alrighty. Any other questions on 20, whatever? 26. Let's do another one. This is number. No, here it is. I think this is a good one. 27, I think. So domain is how far to go to the left and how far to go to the right. Clearly it stops. It doesn't go on forever. Right? There's no arrows or whatever. And there's also holes on the edges. So I can include those numbers. So this lowest x value is -3, highest x value is 3, but I cannot include because there's holes. So you would have to put parentheses. So -3 to 3. And then the range is like, all right, how high did it go? The high on the y is 5, but there's also, again, a hole there and a hole here. So I have to put parentheses on that as well. So -5 and 5. Is there any questions on this one? Yeah, if they were closed, you would put brackets for sure. Remember in class we said, if you want to find the domain of this function, you have to remember what is not allowed. So we know the inside has to be positive, but 0 is okay. So in class, we said, that's how you start. Create this inequality, write this down and say, when you begin, the inside, 15 minus 5x, has to be greater than or equal to 0. So we get this. Solve for x, right? You subtract the 15, divide by -5, and whenever you divide or multiply by negative on both sides, this inequality is going to flip. So this reduces to -3, +3. And then you have your domain, right? How do you read this? Everything is cool when you're below or equal to 3. X is less than or equal to 3. So 3 is the highest value. And if it keeps going, well, we put -infinity. So this arrow is telling you which direction it's going. So if your x is on the left and the arrow is pointing to the left, then everything in that direction is cool, the negative direction. But the starting point is 3 with a bracket. So when you have a square root type, set the inside greater than or equal to 0, and then start solving. Does that make sense? Let's move on. Skip here and there. Let's do this guy here. That is number 30. F of x is equal to x squared over x minus 4. G of x is equal to this nonsense. Find the domain. All right, so let me switch over. Okay, so for f, remember we said whenever you have these kinds of questions, it says the denominator equal to 0 because that's going to tell you what can't be used. So x cannot be equal to 4. So that means that for f, right, domain of, I'll put right here. What's I gonna do? Oh yeah. So we said everything except 4 is okay. So that's what you do. 4 has a hole. So everything after is fine. Everything before is fine. So you have to write the interval for below and above. So everything above 4 would be written this way. From 4 to infinity, 4 to infinity. And negative infinity up until 4 would be this below section. So you would write the domain has to be the union of these two pieces. That's it. Does that make sense? For g, set the denominator equal to 0. Again, factor this guy, that would be what? Double factor? Oh, yeah. So x cannot be -1, x cannot be -8. So we have two holes. We're going to make multiple intervals. -8 has a problem. -1 has a problem. So write everything before and after, and in between. These sections are good. So negative infinity all the way until -8. -8 until -1, everything after 1. So the domain for G is these pieces united together. Union with each other. Any questions on number 30? So, starting to get tired. It's a lot of problems here. This is number 32. So let's go over the concepts here. Do you remember what it meant to put the 2 in here? And we said this is the input, right? This is the x value. So if you were to do that, if you had the equation, you would plug into anywhere you had an x. We don't have the equation, so you just need to understand the concept. We know that means plug in 2 and see what the output is. Well, there's 2. What is the y value here? Because that would be your answer. Right, you see the y? And so the y value is 0. If they write it this way, they mean the y is equal to 3, and the y is equal to 3 at 2 different x values. So you would say that happens at 2 and -2. Does that make sense or not? Sorry, negative. Right. Oh, yeah, it should be -1 and 1. Oh, it just says find one value. I see. Okay. Both would be right. Yeah, that's 32. 33. Remember we talked about increasing and decreasing. So from left to right, if we're going up, that means we're increasing. Left to right, if we're going straight, then that's constant. Increasing, constant, decreasing. So just write the location of when it's happening, combine it together. You would write determine the intervals on which the function is strictly decreasing. So there's only one section. You'd say from 3 to 6 right there. Okay. Piecewise defined function. So they give you a function that's made of two parts. And they give you values. They said as long as it's not equal to 1, the answer will always be -3. That's what this means here. If it's equal to 1, then it's going to be 4. Because these are two constant functions pieced together. So since it's not equal to -1 for -5, you would say -3, -3. If it's equal to 1, then it has to be 4. Not very interesting, but that's what's going on. The last few questions, I think we're going to cut them down a bit. This one is number 36. Remember we said if there's a number, I'm sorry. This is the questions about transforming graphs, or where we shift them up or down, or reflect them, or shift them, whatever. So we said if the number is inside, then you do the opposite. So if it's +4, then you take this guy and move it to the left 4. Since it's -3, you got to move it down 3. So the translation would take the original, move it to the left 4, down 3. That's what this is doing. If it's inside, it's opposite. If it's outside, it's just straight up. If it's outside, it's vertical. If it's inside, it's horizontal. But the next few are similar. Translating. This one's different. This is a little different. Let me show you the answer here. I think this will be our last problem for today. So if it wants us to do negative inside, that's going to be a reflection across the y-axis. If the negative is in front on the outside, then that's a reflection on the x-axis. So this makes it flip up and down. This makes it flipped right and left. Okay. So let me show you. They took this guy and flipped it across this axis. That's how this happened. Do you see it? And then this one, well, since it's the negative was on the inside, on the outside, they take the original, the gray one, and just flip it upside down. And that's it. That's all they want you to remember. It's like, okay, well, what happens? Now, of course, that'll change your values and stuff, but essentially, in a nutshell, it just you flip it and fold it together on the Y. If it's the other way, you flip it down on the X. All right, guys. I think that's enough for today. Do y'all have any other questions about? Let me hit pause here.